there are, for instance, some sensors that report their findings as a pulse width modulated signal. So there's an accelerometer that when you hold it flat, it gives you a square wave, in other words, equal time on and off. As you tilt it one way, the pulses get smaller. As you tilt it the other way, the pulses get bigger. So a very, very different meaning for pulse width modulation, but it's just a way to convey information. As James was asking, there are also these type of motors called servo motors. And they're the motors that you use in model airplanes or model boats that control the flaps and the rudder. And even on the ground, you have a transmitter with the joysticks. You push the joystick one way, the rudder turns one way. You push the joystick the other way, the rudder turns the other way. And the way they control that is with pulse width modulation. So there's a pulse that comes out just like this that says if the square wave if the wave is square, in other words, equal times on and off, then the motor goes to the middle. If the pulse is really short, it goes to the left. If the pulse is really long, it goes to the right, and everywhere in between. And those pulses have different timing, so you wouldn't use the same analog right in order to control that. Instead, you would use the servo library, which is built in. Let's see, examples, servo. So there is a servo library. In other words, someone has taken the time to write a set of commands or statements that make these servo motors go exactly the way you'd like them to go. And it's very much the same type of thing, but the timing is a little different. So that's why servo is written to control servo motors, but when we're trying to control the speed of a plane motor or the brightness of an LED, we use the analog drive.